Hi, in this video I will do some examples for the distance formula, distance of a point from a plane. Part 1, the point is -1 to 0 and the plane is given by an equation in the standard form. So remember that the distance of a point Q from ax plus by plus cz equals to d. This is equal to square root of a square plus b square plus c square in the denominator. In the numerator, you plug in coordinates of q into the equation, a q1 plus b q2 plus c q3, and then bring d to the left hand side and just find absolute value of that. So in this case, the distance then is 3 for x, plug in -1, minus 4 for y, plug in 2, and for z plug in 0. Bring -1 to the other side, so you get +1. Find absolute value of that over 3 squared plus -4 squared plus 1 squared. And that gives us root 9 plus 1625 plus 1. This is 26. And numerator is -3 plus -8 plus 1. And that together gives us -10, but we are looking for its absolute value, which is 10 over root 26. Distance is always positive number. That's why we have absolute value there. Well, that's part 1. For part 2, we have the point is the origin. It means that the coordinates are 0, 0, 0. And the distance in this case, where the equation of the plane is in point normal form, is equal to basically you plug in q into the equation, the left hand side of the equation, find absolute value of that, and then divide it by the length of n. This means that we have 1 squared plus -2 squared plus 1 squared in the denominator. In numerator, you just put exactly the left hand side of the point normal equation. Instead of x, plug in the point. Here the point is 0, 0, 0, the origin. 1, 0, 2, then absolute value. 4 plus 1 plus 1, this is root 6. In the numerator, we have, this is -1, 0, -2. Dot product gives us 1 times -1 plus -2 times 0 plus 1 times -2. And then find absolute value of that. This piece here is -1 plus 0 minus 2, which is -3 over root 6. Well, okay, absolute value, drop the negative sign. This is 3 over root 6. That's part 2. Part 3, the point is 3, 1, -2, but the plane is not given. The equation is not given. We have to find the equation for the plane. So here I need to have a point, 1 point, which is -1, -1, -1, because plane passing through that. And I need a normal vector, yes, n. Normal vector n is not given in the question, but we have to use the information It says the plane is parallel to the vectors u and v. So plane is parallel to that. Normal is perpendicular to the plane. That means that we can take u cross v as our normal vector. In other words, we have to find cross product of 0, 1, 3 and negative 1, 0 and 1. Okay, this we can find by finding 3 determinants. I will write it somewhere here. The first one is ignore the first column, 1, 3, 0, 1. Second one, ignore second column. And third one, ignore the third column. So 0, 1, negative 1, 0. And this gives us 1 minus 0, 0 minus negative 3, and 0 minus negative 1. In other words, the vector 1, negative 3, and 1 is a normal vector to the plane. Now I have a normal vector. I have a point. I can make point normal equation for the plane. Point normal equation. Well, which is n dot x minus the point. This needs to be equal to 0. Then the distance then is obtained by, well, in the denominator we have to find the norm of this guy. In the numerator we have to plug in the point from which we are trying to find the distance into our equation, left hand side of the point normal equation. So this is 3, 1, negative 2 minus negative 1, negative 1, negative 1. So we need to find these numbers. So square each component, add them, and then find the square root. In the numerator, we have 1, negative 3, 1, dot. 3 minus negative 1 is 4. 1 minus negative 1 is 2. Negative 2 minus negative 1 is negative 1. And then in the numerator, we have 4 minus 6 minus 1, absolute value of that, over, this is 1, this is root 11. And the numerator then gives me the final result. Yes, this is negative 7 plus 4, this is negative 3, and that gives us just 3 over root 11.